Not recorded. Okay, so we're recording, and I'll just erase this big line. So we're going to look at just the last couple of bits on equations of straight lines. We're all pretty good at these now. If I have got, and our title today is going to be perpendicular lines. So we have covered this a little bit. Some of you have done some questions on it, which is great. Smaller. But first off, just as a recap, if I have got an equation, let's say y equals 1/3 x minus 4, what is the gradient of this line? Let's have Grayson. Okay, good. So the gradient is 1/3. And Damon, what is the y-intercept? Good, -4. Okay, don't forget the negative. Excellent. What about if I've got something like this? Okay, I did it for you. Okay, how is this different to this one, Liam? Yeah, it's 2y. And in order to be able to pick out the gradient and the y-intercept, it has to be y equals, okay? So how can I make this? Yep, Zaire, good. You just divide everything by 2. So I'm going to divide this by 2. I'm going to divide the 8x by 2. I'm going to divide 6 by 2. Remember, what you do to one thing, you have to do to the whole thing. So that gives me y. Good, Damon, thank you. So what is the gradient, Ian? Excellent. And what is the y-intercept, Ethan? You see it's on your screen? Hopefully. Yep, that's equal to 3. Good. So just be aware of that if you've got something like this. Okay, what about this one? That's 1, that's 2. What about if I've got something like this? 3y minus 4 equals 4, yes. Okay, how is this one different? Yeah, and how do what if I want to work out the gradient and y-intercept of this line, I have to make it look like what? Yeah, it has to be y equals, okay? So how could I rearrange this so it's y equals? Okay, so how do I move this to the other side? Add 4 to both sides, good. And so that gives me good. And then everything by good. Okay, and we have to divide everything by 3. So what does that give me? Liam. Liam. What does that give me? Good. Yeah, 4/3. That's absolutely fine. You could leave it like that, okay? So 2/3. Yep, 4/3. So your gradient is 2/3. And your y-intercept is 4/3. And you could, of course, work it out as a decimal. If you work it out as a decimal, it's going to be what type of decimal? Recurring, good. So you need to put the little dot in. Excellent. Nice one, gentlemen. Okay, right. Let's have a look at our perpendicular lines. Now, if I draw an axis for you. And I want to go this way too. There's been a lot of new software that has come out since all of this, since we're all self-isolating. All quite nice. Yeah, maybe. The wall said it can be free for the first while. -3, -4, -5, -6. All right, I'm going to plot a 2 lines on here. And let's see, this one. And let's make it a bit thinner. Pick me a color. Good choice. Okay, let's go like this. And pick me another color. What, this one? It's like a maroony, but that'll do. Oh no! Okay, that's like a brownie. Okay, I have got 2 lines. And these 2 lines, let's go for blue. Let's call this one D. Let's call this one CD. And these 2 lines meet at 90 degrees. Okay, they are perpendicular. Okay? Okay, so they meet at 90 degrees. They are perpendicular. What I would like you to do is, I want you to work out the gradient of line AB for me, and then the gradient of CD. Okay, so remember, you do that by making the rise over run. Okay, so doing the little triangle. I'm going to pause the recording and have a go at that for me now. Okay, record again. And so the first one, line AB, let's use green. Okay, and we're going to make it into a triangle. Remember, you want to pick points that go through whole numbers. So I can do this one. What did we get for the gradient of AB? Yeah, excellent. 1 over 2. Your rise is 1, your run is 2, your vertical is 1, your run is 2. What did we get for our gradient of the other one? Yeah, now careful, it's sloping downwards. So it's -2 over 1, which is just -2. Yep. Is that okay with everyone? So what do we notice? Liam and Ethan, be quiet, because I've yesterday about this. But what do we notice about the gradients of 2 lines that are perpendicular? They're the same, but what? Okay, one's negative, one's positive. That's important. And the fraction is flipped. Right, good. What do we notice about? What do we notice? Sorry, I just want to put this up so you have it. The gradients of perpendicular lines. Okay, so we said if one is positive, the other is... Okay. And I should really say, and vice versa. So all I mean there is one is negative, then the other is positive. And what else did we notice? Yeah. And we also noticed that the fraction is flipped. So let's say I've got a equation, y is equal to 4x. What would be the equation of a straight line that would be perpendicular to this? Okay, almost, Damon. Yep, it's going to be negative because you change the sign, and then you flip the 4. And remember, 4 is just 4 over 1, so when I flip it, yeah, it's going to become 1 over 4. So these would be perpendicular. Okay, what about if I have got an equation y equals negative 3 over 2x? What would be a line that is perpendicular to that? Let's have Ian, could you answer? Ian, could you give me an answer for that one? So you flip it? Yeah. 2x over 3 or 2 over 3x. And if it's negative, then it becomes positive. Good, okay. So if it's positive, it becomes negative. If it's negative, it becomes positive. And you flip it, okay? Does that kind of make sense? Okay, good. Now, this should be revision from last time. Let me